dealing with y equals ax squared plus bx plus c, or maybe another form of y equals that was quadratic. Because we're actually solving, the y is now 0, and in fact when we're solving, what are we actually calculating? The x-intercepts, yeah, because that's when y is 0, right? And x-intercepts were also called solutions. It was also called roots. Okay, so solve x squared equals 25. What do we get? Nobody wants to say because they think it's too easy. Yeah, how do you undo a square? You square root it. So what do you get? X equals? Oh, that's what you think it was. But there's two answers. Plus or minus. Plus or minus. Think about that for a second. What can I sub into x squared and get 25? Not just 5 squared, but negative 5 times negative 5 is positive 25 as well. So to undo squaring, we want to take the square root of both sides, but have to remember to include both the positive and negative square root. There is a difference between x equals the square root of 25. How many answers would I get there? 1. X can only equal 5. You can't put negative 5 in x because how can a square root equal a negative number? You can't. But does everybody see here? When we're subbing the negative 5 in there, it actually means negative 5 the whole thing squared, which is 25. So it does work. Do you see that? Whereas here, we're subbing 5 in for x, right? You can't get a negative 5 equal to the square root of 5. Square root of 25, sorry. Okay. Let's solve these quadratics by isolating x and by undoing. So, what would we do first here for a? Yeah, move the 9 over. We're in grade 11. We don't have to show add 9, just do it. X squared equals 9. Then we square root it, we get? Okay, so now what we're going to do to undo a squaring, we square root from x squared to x step. So when we square root 9, we don't get 81, we get? Not just 3, plus or minus 3, 2 answers. Okay, what would we do here? Divide by 2 to both sides. You don't need to show that step. Just go. X squared equals 4. What does x equal? Plus or minus 2. Ooh, this one looks a little different. What do we do here? Do you think we need to multiply it all out? No. It's actually in a perfect square form. So if we divide by 3 to both sides, what do we get? X minus 1, the whole thing squared equals 4. Now do you see I can square root both sides? What do I get when I square root x minus 1, the whole thing squared? It undoes the square, right? The square root undoes the square, and the square undoes the square root. Same thing. It'll get back to the original form, right? It's like multiplying and dividing. It undoes each other. So, x minus 1. But when I square root 4, what do I get? No, not just 2. Plus or minus 2. Well, what does that mean to solve for x? Huh? I have to move. There's 2 answers. So sometimes when you write it as plus or minus 2, it's a little confusing. So what you might want to do is split it up into 2 solutions. So you get x minus 1 equals positive 2 and x minus 1 equals negative 2. You see what I'm saying? So now when I move the 1 over to the other side, I get x equals 3. And what do I get over here? X equals negative 1. Now, you know, the best thing about algebra is once you get a solution, you can just sub it back in and see if it works, right? So let's sub in 3. What's 3 minus 1? What's 2 squared? What's 4 times 3? 12. It works. Let's sub in negative 1. What's negative 1 subtract 1? Stop it. Negative 2. What's negative 2 squared? 4. What's 4 times 3? See, it works. Yes? Okay, moving on. We got to move the 10 over. X squared I'm going to do it in 2 steps because I might lose somebody if I do it in 1 step here. Equals 10. Divide by 3. X squared equals 10 over 3. What's wrong? Who cares? It's just a number. So now what does x equal? What does x equal? Plus or minus the square root of 10 over 3. Is there anything that I could actually square root in 10 or 3? No. Because back in grade 10 you learned that you could actually square root the top and square root the bottom separately. So if this, for instance, was 9, well, 9 over 3 is 3, but say this was 16, you could square root the top and get a 4, and then leave it as root 3 at the bottom. Yeah? Okay, next one. What do we do first? Divide by -2, so we get x plus 3, the whole thing squared equals what? 10. Thank you. Then it's a perfect square, so we square root it. We get x plus 3 equals plus or minus the square root of 10. Are we good? Okay. So we're going to split this into 2. We get x plus 3 equals positive square root of 10. And x plus 3 equals negative square root of 10. Yes? Yes? Okay, so then move the 3 over. What do we get? Do we get root 7? I like your answer. What? You should be saying what? That's absolutely wrong. You can't subtract a 3 and a radical together. They have to be like radicals. So what's my answer? Root 10 subtract 3. You have to leave it like that. Or you could grab your calculator at this point and get a decimal approximation for it. But you can't actually do anything together with it. And so what do we get over here? Negative root 10 subtract 3. Okay, any questions before we move on? Okay. So now, products which equal 0. An important property is, if A times B equals 0, then what would make it true? What's the only way that you can get a product of 0? You must be multiplying by 0. So either A equals 0 or B equals 0. That's the only way this would ever work. Okay? So all the people that solve by factoring, you better have the right side or one of the sides equal to 0, because that's the only way you can solve with this 0 product principle. So we can use this idea to solve quadratics that we cannot undo. So, example 3. X squared plus 4x plus 3 equals 0. Hint. Can you make a product that equals 0? Can you figure out something times something equals 0? No, but it has to do with this equation here. Good try though. Yeah, anything times 0 is 0. So what is it going to be? X plus 3 times x plus 1. Let's check. FOIL this out. Do I get x squared plus 4x plus 3? Yes. So what is x equal then? How would I make it equal to 0? No, x plus 3 would equal 0, and x plus 1 would have to equal 0. So what does x have to equal? Huh? Not 3 and 1. Huh? It would have to be minus 3 and minus 1. Yes. How do you make x plus 3 equal to 0? Stop it.
Wow.
Set it equal to 0 and solve. Basic 8th grade algebra. Maybe even 7th grade. Move the 3 over. We get x equals negative 3. Also, x plus 1 could possibly equal 0. Because remember, this is a product. A times B equals 0. So what could this A could be 0, not x. This thing could be 0, or this thing could be 0. So that means x plus 1 could equal 0, so x can equal -1. So let's check. If I substitute -3 into my original question, what's -3 the whole thing squared? What's -3 times 4? -12. What's 9 subtract 12? -3. What's -3 plus 3? 0. It works. Let's sub in -1. -1 squared. 1. -1 times 4. -4. What's 1 minus 4? -3 plus 3 equals 0. Do you see it works? Okay, let's solve. How do I make 2x squared minus 3x minus 2 equal to 0? I factor it to try to get a product. So, the only way you can get 2x squared, it must be 2x and x. The only way you can get a product of 2, it must be 2 and 1. So play around with the 2 and 1. What does it have to be? Yes. So that means we have -4 plus 1. So what does x have to equal? Who can tell me? -1 and plus 2. Well, the plus 2 is correct. The -1 is not correct. -1/2 would be correct. And if you're having trouble getting -1/2, we will write it out. I'll write it out in red just so you know. Remembering that we made a product. In order to get a product of 0, that means this set equal to 0. 2x plus 1 equals 0. Move it over by subtracting. 2x equals -1. Not x equals -1, 2x equals -1. Divide by 2, I get x equals -1/2. This one's pretty, I think most people get this one as that already, right? You can mentally move the 2 over and solve, right? Yes? Okay, let's do it. Let's do the next one. Actually, let's do B, C, and D at this point. All right, so we're going to factor this. Okay, a mistake that you will lose marks on is changing. A mistake that you will lose marks on the test is if you go from an equation. Does everybody know what an equation means? Has an equal side and a left side and a right side, right? An expression does not have an equal sign, even though we sometimes put equals with the answer. It's technically an expression and it doesn't have an equals. That's why usually teachers train you with expressions, just follow it down, don't even put an equal sign. So if you factor and drop this equals, you just lost a half mark because you changed an equation into an expression. So make sure you put equals 0, because the only reason this works is that you're getting a product that equals 0. So anyways, 3x and x, it looks like it has to be, what, 5 and 2? Okay, and both plus. So then what does x equal? -2/3 and -5. Does anybody need me to show my work how I got -2/3 and -5? You're good? Okay. No, a comma. They're both correct answers. So the reason, if you were to substitute either of them in, they both give you 0 on the right side, right? So they both actually work. So although when we were doing the 0 product property, I said this or this has to be equal 0, when we solve it, we end up getting both of them equal to 0, right? They both end up working. A quadratic usually means we have 2 solutions. Does everybody remember what a quadratic looks like? Looks like this, right? Do you see why we have 2 solutions usually? Because we get 2 x-intercepts. That's where the y went to 0. So sometimes you might get no solutions. That's when you have a quadratic that didn't touch the x-axis. Or if I touch it just once, that would be the only case where I would get just 1 solution. Doesn't happen too often, right? More than likely you'll get 2 solutions because you have way more graphs that look like this than that, right? Okay, so I saw a lot of errors on this. People were trying to say it worked, but it didn't. 3y and y. And I think what some people put is they put a 4 and a 2, which is correct. However, they they made one negative and one positive, which won't give you positive 8. They both have to be negative here, right? They both have to be negative for this to work. So the only way this will work is a 4 and a 2 like this. So then, so what do we get for y then? 4/3 and positive 2. Okay, I gave you the hint. I only give you this once. You have to know if you get an equation and it equals 5, the zero product doesn't work unless you have a side equal to 0. You have to move the 5 over. It's easy, right? 8a squared plus 18a minus 5 equals 0. And there'll still be somebody in class that will try to factor this side and set it equal to 5. It doesn't work. How many solutions could you get for a product of 5? How many solutions can you get for a product of 5? The correct answer is infinite. Some of you just think, oh, 1 and 5, that's it. No. What about 5/2 times 2? What about, 5/3 times 3? You could have decimals. How about 2.5 times 2? You could go on and on and on, but there's only one way to get a product of 0, and that's why this works. Because you have to have one side equal to 0 and make it into a product. Okay, so 5 and 1. Now, I'm thinking it's going to be 4 and 2 because that's the only way I'm going to get close to anything that's going to work here. So that gives me a 20. Oh, I didn't write a 2. No. Sorry. I'll try that again. There we go. And in order to get a negative product and a positive sign, my 20 must be a plus and this must be the minus. Again, always check to see if you can FOIL it and get back where you started. So what does A equal? How about positive 1/4 and negative 5/2? Make sure your signs are correct. Again, if you can sub this back in, this one might be a little harder to sub in because it's fractions, but it still will work. Okay, this last one, actually when you get ones like this, you might think it's hard right now, but this is probably the easiest ones. If you factor this, what do you get? You can take out a GCF of 5x and you're left with x minus 2. Does everybody see? I now have a product equal to 0. So if you set the factor, I'm just going to show my work in this step just so you can see. 5x equals 0 and x minus 2 equals 0. Do you see if you divide by 5 to both sides? I'm actually even show dividing by 5 just for one person in the class here. X equals 0. And then if I move the 2 over, x equals 2. Do you see I get 0 and 2? And just for fun, let's sub 0 in. What do we get? 0 squared. 0 times 5. 0. What's 10 times 0? 0. What's 0 minus 0? 0. Do you see 0 is a legit solution? People think that's not really a solution, but it is. If we put 2 in there, 2 squared is 4. 4 times 5. 20. 2 goes into here. 10 times 2. 20. What's 20 minus 20? 0. Okay. Whew, I'm exhausted. Anyways, dock jumping is an exciting dog event in which dogs compete for the longest jumping distance from a dock into a body of water. I guess so. I got this from somewhere. The path of a Jack Russell Terrier on a particular jump can be approximated by the following quadratic formula, where h is the height and d is the horizontal distance from the base of the dock. Okay, so we need to determine the horizontal jump. So the thing here is can anybody tell me just a quick sketch of this graph? First off, does this quadratic open up or down? Down. How do I know it opens down? It's negative. Can anybody tell me what the Y-intercept is? 2. How do I know that? I put x is 0, or in this case d is 0, d is 0. What do I get? 2. So it's starting at a height of 2 and it's looking like this. Does everybody see? Why would it start at a height of 2 for the dog? They're jumping from a dock into the water. Does everybody see that? Okay, so what they want to know here is they want to know what this is, this horizontal distance. So what do I actually have to figure out here? The x-intercept. And what happens if I get an x-intercept on this side over here?
Fell back.
I would throw that one away because it doesn't make sense, right? We can't have a negative horizontal distance.
Yeah, what if he falls off the top?
Okay, so in order to find the x-intercepts, I set y to 0. In this case, my y is my h of d. So I'm going to have 0 equals negative 3 over 10 d squared plus 11 over 10 d plus 2. And there's a heck of a lot of fractions going on here. And I don't really like fractions, so let's get rid of them. How can I do that? Multiply by 10. Now this is different than factoring with an expression. Does everybody understand the magnificent magic of algebra is whatever you do to one side, you do the other, and it doesn't alter the question at all? So if I multiply both sides by 10, it'll make my life really easy, right?
Yes.
If I multiply 0 by 10, what do I get? If I multiply this whole side by 10, what do I get for negative 3/10 d squared? Negative 3d squared. Very good. And what do I get when I multiply this by 10? 11d. And what do I get when I multiply the 2 by 10? I get 20. Now, the other thing I will highly, highly recommend, I don't even want you to try ever solving by factoring when your a is negative. There is so many mistakes that could occur because you're trying to factor with this negative 3. There's an easy trick. All you have to do is multiply by negative 1 to both sides. But something even easier than that, which essentially you're doing is multiplying by negative 1 to both sides. Switch every single sign. That's multiplying to negative 1 to both sides. Does everybody see that? So if you switch all the signs, multiplying by negative 1 switches the sign. So if I switch the sign to 0, it's still 0. What do you get here? 3d squared minus 11d minus 20. Does everybody see? Yes? You might want to look at this question again later. So now we're going to factor this. 3d and d. Yes? Factors of 20. There's a few of them. So I'll give you a second to think of what's going to work so you get a negative 11 in the middle. So you should get a 5 and a 4, and you need a minus 15 plus 4. So what do you get? You get d equals negative 4 over 3, which looks like it's that solution right there. And you also get positive 5, which is that solution right there. So we reject negative 4/3. I think this is the first time you actually got stuff that you reject, right? So what you have to do is if you end up getting two solutions and you're not, and you know one of them can't be, you show the solution and you put a cross, like a line through it, but I should be able to read it. This is how you reject a solution. Okay? I should be able to read it because some people go like this and then I can't read it. You don't get marks for that. Okay? So make sure you only put a little line through it. I should be able to still read it. Show your rejection, and that is 5. So because this is a word question, therefore, the horizontal distance is, let's spell is, 5, is it meters? Feet. Where does it say feet? Oh yeah, it does, feet. Thank you very much. 5 feet. Okay. How are we doing? Another word question. 5 feet. I think that's a legit. The length of an outdoor lacrosse field is 10 meters less than twice the width. The area of the field is 6,600 meters squared. Determine the dimensions of an outdoor lacrosse field. So what would be the first thing we do here? Huh? We would draw a picture. Here's my lacrosse field. And it's saying that the length is 10 meters less than the width, twice the width. So What are we going to let a variable be? Or we could have W equal to width if you wanted, right? So my width is usually the shorter of the two, length is longer. And it's saying the length is 10 meters less than twice the width. How would I write 10 meters less than twice the width? Not W squared. 2W minus 10. 10 meters less than twice. Twice is 2W, not W squared. And it's saying the area of a rectangle is length times width. It's saying the area is 6,600 meters, and my length is 2W minus 10, and my width is just W. How would I solve an equation that looks like this? How would I solve this equation that looks like this? You need to multiply it out and move that 6,600 over to the other side. So I'm going to do it in 2 steps here. If I multiply this out, I get 2W squared minus 10W. If I move this over, I get 2W squared minus 10W minus 6,600. Okay, so again, this is the beauty of algebra. Instead of factoring out a 2, let's just divide the 2 out of there, right? We have 2 sides. We can divide both sides by 2. What do we get? 0 equals W squared minus 5W minus 3,300. And you might say, holy smokes, I don't know all the factors of 3,300. It's got to be something that's pretty close together if we have a middle term of 5, minus 5 to be exact. Can anybody come up with it? Huh? 12. We can grab our calculator at this point. If you want. 66 and 50. They're not close enough. Does anybody know a fast way of finding numbers close that multiply? Something times something is 3,300, and the numbers have to be close. The closest one together would be if you square rooted it, right? So what's the square root of 3,300? 60 and 55, Ryland says. Very good. So 60 and 55. So we need a minus 60 and a plus 55 for this to work. Which means W equals 60 and minus 55. Can we have a minus 55 for a width? No, so we reject it. Does everybody see we reject it? And we say, therefore, what are we actually answering here? What are the dimensions? And this is in meters. Therefore, the dimensions are, the width is 60 meters by, what's my length going to be? Remember, my length is 10 less than twice. Twice 60 is 120. 10 less would be 110. Does anybody know if this is the, how big a lacrosse field is? Anybody play lacrosse? Yeah.